Hello everyone, this is Dr. Zach. So for today's lesson preview, you are to match each slope field with its differential equation. If you take a look at your first differential equation, it is a function of x. So if x is equal to 2, then all of your slopes would equal 2. So check out your x values all equal 2 and match which one works. Use that same idea in order to find when all the slopes are equal to your y value. So instead of looking at a vertical, you will look at it horizontally. And then of course our third one, you have dy dx is a combination of both x and y. Afterwards, you are to draw the particular solution for your function through the value 1, 1. So for example, if you plotted 1, 1, then you will follow these slope fields, this little tiny field of values to draw what the original function would look like. So you have a mini view of all the little slopes, and then when you put the slopes together, that should give you your slope field. Now, AP does not want you to put arrows on your problem, so please do not put arrows. Just draw your graph to the edge of the region given. So our goal for today is to use Euler's method to write an approximation for the integrals of each function. Now we're not actually able to find these integrals, so we want to use ideas centered on slope fields to find estimated values. We begin by writing the equation of a tangent line at x equals 315 degrees so that we can estimate the sine of 314 degrees. So the function that we're interested in is the sine of x. What we know from last year is that we could use the equation of a tangent line, y minus y1 equals your slope times x minus x1. As you'll recall, the slope is the derivative at the point, so we're going to write the equation of the tangent line at that point. And in this problem, f prime of x is going to be the cosine of x, and specifically we're interested in the point 315 degrees and the sine of 315 degrees, because these are values on the unit circle, and we should know what the sine of 315 degrees is. Of course, that is going to be negative square root 2 over 2, and then we'll have our 315 degrees. So we now have our x and the y that we can use for the equation of our tangent line. So y plus the square root of 2 over 2 equals the slope. Well, the slope is going to be the cosine of 315 degrees, which is root 2 over 2, times x minus 315 degrees. Now you know that we have a small problem if we are adding and subtracting degrees when trying to figure out this value. So we need to multiply by pi over 180 degrees to eliminate the degree as part of our problem. We then know that y is going to be equal to negative root 2 over 2 plus our root 2 over 2. Substitute in your x value that we were actually interested in, our 314 degrees minus 315 degrees multiplied by pi over 180. Now, if this were an AP exam, you could leave your answer just like that. However, if we're going to round to 3 decimals, the final answer that we should get is negative 1.414. So if we can write the equation of a tangent line, we can estimate our y values. Now, we're going to take this idea and combine it with the idea of a slope field. So a slope field gives us all the derivatives at these points. So we're taking lines and pointing them in the direction of our function. What Euler's method does is it takes all these little tiny linear approximations to recreate a numerical solution for our differential equation. We might not be able to integrate, but we're going to be able to write and draw these different values to estimate what's happening. So we have an initial value. So we know the slope, we know the point, we can write the equation of the tangent line. We follow that line to a new x value. And that x value, once we substitute it into our linear approximation, will give us a new y value. Again, we can calculate the slope because we know the differential equation. We know the point, our new x value, our new y value, and we can write the equation of a tangent line again. And the equation of that tangent line can then be followed to our new x value, and that will give us a new y value. We will continue this process until we get to the value that we seek. So if we're looking for y at 4, we will stop once we get to x equals 4. For example 2, let's use Euler's method in order to take this differential and try to estimate y at 4. I'm going to give you a picture of what's happening before we begin. So the true equation was drawn for you. You don't often get that value, but in this case it was drawn. We're going to have an initial value of 0, 1. We're going to write the equation of the tangent line and then figure out the new y value given that x is 0.5. Then we'll write the equation of a tangent line, come up with our new y value given that your x value is 1. And we're going to follow this through until we get to x is equal to 4. For this example, we want to take 3 steps. So our initial value starts at x equals 1. Let's figure out how far these steps are going to be. So your delta x, or the length of your step, is going to be 4 minus 1 divided by the number of steps, which is 3. That comes out to be 1, which would be very nice. We're going to draw a table of values to keep our data organized. So we'll have our x, our y, and then we should also put in dy dx. With that, we know that we're starting at 1, and we're going to count by 1s until we get to 4, so that'll be 2, 3, 4. So we're going to have to write the equation of a tangent line 3 times. For our first one, we know that y equals your y1 plus your slope times x minus your x1, and let's fill in the information. So y is going to be equal to 1 plus the slope. Well, the slope comes from our differential equation, x minus 2 times y. So we have the slope is negative 1 times x minus 1. And now we're going to let x equal 2. The reason we're letting x equal 2 is when we take a look, the next value for x is 2. When x is equal to 2, we have 1 plus negative 1 times 1, which tells us that our new y value is 0. Okay, we do it again. Next, we're going to let y equal our y1, which is 0, plus the slope. Well, where does the slope come from? That'll be your x minus 2 times 0. Slope is 2, and then we will have x minus 2. And this time, we're going to let our x value equal 3. Once we let x equal 3, we will have our new y value. So that tells us that we get 0 plus 2 times 3 minus 1, which is 2. All right, we're going to go one more step. And with that step, this time, we're going to follow y equals your y value, which is 2, plus your slope. Well, the slope comes from 3 minus 2 times my y value. So this time it is negative 1. Then we will have x minus 3. We're going to let x equal 4. And once we do that, we'll have 2 plus negative 1 times 1, which gives us 1. So y at 4 is approximately equal to 1 for this problem. When you take your AP exam, make certain that you draw a table of values. Complete the table. This is what will be graded when you complete your AP exam, that table of values. And of course, you should make a statement as to the answer once your problem's been completed. Next, we're going to use a calculator to complete a 10-step problem. So we're going to follow the same idea. This time, you're going to let delta x be equal to 4 minus 1 divided by 10, or 3 over 10. Draw your table of values. This is the only part you're going to have to present. You have your x, you have your y. Your x started at 1, and your y value for 1 was equal to 1. You want to count until you get all the way to 4. And once we do that, fill in your values for all the x and y. Use the program that you've created or downloaded in your calculator and fill in your x and y answers. For this problem, make certain that you have downloaded the program in your calculator, use 10 steps, compare the answers that I've provided in my table. You are to complete the table for your notes. For question number 1, y at 0 is equal to 1. So now, make your table of values. We'll have our x and our y. We have 0 with 1. We're going to use 2 steps to estimate y at 1, which tells us that our delta x is 1 minus 0 divided by 2, or 1/2. So the steps we're going to take will be 0, 1/2, then 1. Write the equation of our tangent line. Y is equal to our y value plus our slope, and the slope, when we substitute, is going to be 1, and then we'll have x minus our 0 in this case. Next, we will let x equal 1/2. Do some substitution. Y is equal to 1 plus 1/2. So our new y value is 3/2. Write another equation. We're going to have y equals our 3/2 plus the slope. So the slope of this one is e to the 3/4, and then we'll have x minus 1/2. When we let x equal 1, we end up with a new y, which will be 3/2 plus e to the 3/4 times 1/2. Put this all together, and we will have 3 plus e to the 3/4 divided by 2 as our new y value. So y at 1 is approximately equal to 3 plus e to the 3/4 divided by 2. Notice again, I drew a table. The table is what AP is expecting, and I have stated my answer. So again, you will use your calculator and your formula with 10 steps to estimate y at 1. Make certain you provide your table of values and the final solution. So you can see number 2 is written just a little differently than the others. This time you're asked to approximate y at negative 3.8 plus k over 8. You're given different values for k, and we're still going to use Euler's method. So again, let's make a table of values. We have our x, we will have our y. Substitute in your negative 3.8, and then we'll add in negative 3.8 plus 1 over 8, negative 3.8 plus 2 over 8, negative 3.8 plus 3 over 8, and negative 3.8 plus 4 over 8. Now we're going to use Euler's method. It's like 4 times. So we have y is equal to our y value, which in this case starts at negative 1, plus our slope, and the slope is found by substituting in your y value with the sign of negative 3.8. After that, we're going to multiply by our x minus your delta minus your next value, which you should have figured out is 0.125 for each one of these. Come up with this value, and that will give you your new y value. Once we have that new y value, we get to do this all over again. So our next equation is going to be y equals the new y value, negative 0.935, plus, now following your differential equation, put in your y value, and then your x value. So we have the sign of our new x value, which is negative 3.8 plus 1 over 8, and that is going to be multiplied by your delta x, which is 0.125. Simplify that just a little bit, we come up with negative 0.8655. All right, so now you're going to have to do it again. So write down what your y value equals and fill it in for the next. Then do it one more time. Write down what your y value will equal and fill it in. State next. Well, that's what we were looking for, all of these y values. For question B, we're to solve the given equation to get a formula for y of x. So when we look at the given equation, your differential, you have dy over dx is equal to y sine of x. So as you look at that, do you see that we could use separation of variables to solve it? We have our dy over y is equal to the sine of x dx. Let's integrate both sides. We're going to get the natural log, absolute value of y, equals the negative cosine of x plus c. So if we use our initial value to find our c right now, we know our c value is going to be equal to negative 0.791. So now we'll take that c value and rewrite our equation. We have the natural log of absolute value of y is going to be equal to the negative cosine of x minus 0.791. So that tells us that y is equal to e to the negative cosine of x minus 0.791. After that, you can fill in your values for x so that you can do a comparison. So for example, when we have x is equal to negative 3.675, or when k is equal to 1, your value for y is negative 0.916174. So you should be able to fill in the rest of the x values to get your y values. So after you do that, compare the exact answer to your estimated answer. Write down what you notice. Were the estimates above or below these exact values? Now, we could use calculus to tell whether the estimate's above or below the exact value if we know some information about the second derivative. So if your second derivative is less than 0, that would make your function concave down. And if your function's concave down, you would have drawn tangent lines on top of the graph. So that would mean you would have an overestimate when you do a numerical approximation. However, if your second derivative is greater than 0, your original function is concave up. So the tangent lines are under the graph. And that would tell you that your estimates are under estimates because your tangent line is under the graph. So give the lesson practice a nice try. I've stated some answers for you. When you use your calculator, make certain that your program is correct. Questions 6 and 7 are typical AP questions. So you are to find a second derivative for part A. Make certain that you are going to replace the dy dx within your answer. For question B, you're looking for a relative min or a relative max or neither. Make certain that you justify your answer. So when you justify your answer, you have to write about where the function increases or decreases. Make certain that you're very precise with your language. Use y or use y prime. Do not use the word it. For question C, again, you're given that y is equal to some function g of x. And you are given a particular point. So you're asked to find the limit. So when you show your work, make certain you justify your answer using L'Hopital's rule. And for question D, you're to use Euler's method, starting at x equals 0 with 2 steps. This, of course, is a no calculator problem, so give this a good try. Question number 7. Again, this is a typical AP question. So give this an excellent try.